Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the details of DTC P0125, which indicates an ECT sensor 1 malfunction or slow response, specifically affecting the Honda Civic models from 2011 to 2015. The Engine Coolant Temperature, ECT sensor, plays a crucial role in monitoring the temperature of the engine coolant to ensure optimal engine performance and emissions control. Anomalies in the sensor's readings can trigger error codes, leading to poor engine performance and increased emissions. The location of the ECT sensor 1 is typically near the engine block, facilitating efficient temperature measurement. Understanding this malfunction is essential for accurate diagnostics and effective repair strategies. Let's proceed by exploring the error description, its causes, symptoms, and the necessary steps for troubleshooting. DTC P0125 arises from issues related to ECT sensor 1, which is primarily responsible for monitoring the temperature of the engine coolant. Located near the engine block, this sensor plays a pivotal role in relaying crucial temperature data to the Engine Control Module, ECM. If the ECT sensor malfunctions or responds slowly, it can lead to inaccuracies in the engine temperature readings. This can compromise engine performance by causing improper air-fuel mixtures and inadequate emissions control, ultimately affecting fuel efficiency and increasing the emission levels. As such, addressing this DTC promptly is integral to maintaining engine health and compliance with environmental regulations. Various factors can trigger the DTC P0125, and understanding these is vital for effective troubleshooting. One primary cause is a faulty ECT sensor 1, which directly impacts the readings sent to the ECM. Poor electrical connections and loose terminals at the ECT sensor or the ECM can also cause unreliable signals, leading to the generation of this code. Furthermore, issues with the thermostat can affect overall engine temperatures, indirectly impacting the ECT readings. Carefully examining each of these components is essential for diagnosing the root cause of the malfunction. Ensuring accurate repairs can be implemented swiftly. The symptoms arising from DTC P0125 can significantly impact the vehicle's operation. Drivers may notice poor engine performance, which can manifest as rough idling, stalling, or sluggish acceleration. Increased emissions may also be observed due to improper fuel mixture settings, instructed by an inaccurate ECT sensor reading, potentially leading to a failed emissions test. Additionally, the driver may experience warnings from the check engine light on the dashboard, indicating a problem needing attention. It is vital to address these symptoms promptly to prevent further damage to the engine and ensure compliance with emission standards. The first step in troubleshooting DTC P0125 involves a systematic check of ECT sensor 1. Begin by starting the engine and allowing it to idle for at least 5 minutes. This will enable the engine to reach normal operating conditions, essential for accurate readings. Following this, utilize the Honda Diagnostic System HDS to check the data listed for ECT sensor 1. If the displayed temperature is 0 degrees Fahrenheit, -18 degrees Celsius or less, this indicates a possible sensor failure. In such cases, inspect for poor connections or loose terminals at ECT sensor 1, ECT sensor 2, and the ECM. If no issues are found, replacing ECT sensor 1 may be necessary before proceeding to repair verification. In the second troubleshooting step, verifying the problem further constitutes the main action. First, turn the ignition switch to the lock 0 position and allow the engine to cool down to 104 degrees Fahrenheit, 40 degrees Celsius, or lower. Once this is achieved, restart the engine and let it idle until ECT sensor 1 reaches approximately 158 degrees Fahrenheit, or 70 degrees Celsius. Check ECT sensor 2 data with the HDS. If both sensors read around 158 degrees Fahrenheit, 70 degrees Celsius, the failure is confirmed, indicating that further investigation is warranted. Conversely, if only ECT sensor 1 shows an appropriate temperature, the system may currently be operating correctly, necessitating an inspection of connections and terminals for possible issues. The third troubleshooting step centers around verifying the thermostat's condition. Begin by conducting a thorough examination of the thermostat to determine whether it is functioning correctly. A faulty thermostat can significantly impact the engine's cooling system, leading to erroneous temperature readings from the ECT sensors. If the thermostat is confirmed to be operational, ensure that there are no poor connections or loose terminals at ECT sensor 1, ECT sensor 2, or the ECM. Should the connections appear satisfactory and the thermostat is functional, undertake the replacement of ECT sensor 1. Following any repairs or replacements, it is crucial to perform the repair verification step to ensure that the issue has been resolved. After completing the necessary repairs, it is essential to verify the effectiveness of all actions taken. Start by turning the ignition switch to the on-to position. Utilize the HDS to reset the engine control module, ECM, which clears any stored fault codes pertaining to ECT sensor 1. After resetting, again turn the ignition to the lock 0 position and let the engine cool to no more than 104 degrees Fahrenheit, 40 degrees Celsius. Restart the engine and let it idle until ECT sensor 1 reaches approximately 158 degrees Fahrenheit, 70 degrees Celsius. It is vital at this stage to check that ECT sensor 2 confirms a similar reading. If both sensors align, further inspection for any poor connections or loose terminals becomes necessary, leading back to step 1 should discrepancies arise. Preventive maintenance is a crucial aspect of ensuring the longevity of vehicle components and avoiding DTCs like P0125 in the future. Regularly inspecting the ECT sensor and its connections can help identify potential issues before they escalate into more significant problems. Ensuring that connectors and terminals are tight can prevent intermittent faults that are often difficult to trace. Additionally, maintaining the overall health of the engine's cooling system, including the thermostat, can help ensure more accurate temperature readings and improved vehicle performance. Implementing a routine schedule for these inspections can save time and costs associated with unexpected repairs, ultimately enhancing vehicle reliability. In conclusion, understanding DTC P0125's implications and the role of the ECT sensor is vital for effective repair strategies. The systematic troubleshooting process includes verifying sensor data, checking connections, and ensuring the thermostat functions properly. Following these steps meticulously is crucial to identifying and resolving the underlying issues triggering the DTC. Once repairs are completed, diligent verification ensures that the problem does not recur, maintaining engine performance and efficiency. Lastly, committing to preventive maintenance can substantially reduce the likelihood of encountering similar issues in the future, promoting a reliable driving experience. Please like and subscribe to the channel. See you next time.